Hello, welcome to my talk. I'm Elizabeta Šimunović from Faculty of Science, University of Split, Croatia. The research student's understanding of the changing seasons that I will present to you was conducted with my mentor, Ana Sušac, from Faculty of Electrical Engineering and Computing, University of Zagreb, Croatia, and with colleagues Italo Testa and Silvia Galano from University Federico II, Italy. Here is the content of the presentation. To begin with, it is important to say that the phenomenon of changing seasons is part of our everyday lives, but explaining this experience to students is very demanding and unintuitive. In elementary school of the Croatian education system, students become truly familiar with facts about the seasons and their impact on the functioning of plants, animals, people and climate, but the cause of the change of seasons is learned once. We are aware that the use of visualizations in teaching is becoming more widespread and requires students to develop competencies for their interpretation. Therefore, the research question of this research are: do visual representations influence students' understanding of the change of seasons, and how does students' visual attention to a representation affect their understanding of the change of seasons? The reviewed literature is divided into 4 groups, and here are the main conclusions. The findings of many astronomical studies confirm that regardless of the respondents' education and age, the belief that the distance between the Earths, of part of the Earth, and the Sun is the cause of the change of seasons is firmly rooted. Research on the influence of visualization on learning learned that a large number of visualizations in textbooks attract students' attention, but complexity of the images often exceeds the students' ability to interpret them. Research on visualizations of the changing seasons expired that individual elements of visualization do not have a strong enough effect on students' construction of concepts, and effectiveness of new designs needs to be empirically confirmed. Eye-checking research results are: students find it easier to extract information from textual content compared to graphical and pictorial representation when answering conceptual questions, and abstract illustration encourages more efficient word processing because it requires greater intellectual effort in integrating textual and visual information. The type of study is mixed. It includes pre-test, interview, and measuring attention. During February this year, 62 first-grade high school students participate in the research. They are about 14 to 15 years old. This diagram shows the research design. The research consists of 3 phases, each conducted 1 week apart. In the first phase, students read a text about the causes of the changes to refresh their memory. After a week, they took a pretest and according to their results were divided into 4 groups. In the final phase, students participate in interviews during which they watched a visualization on a computer and verbally explained why the seasons change. While looking at the screen, a camera located below the screen tracked their eye movements. On the right side of the slide, we can see details of visualizations of each group. Visualizations in groups 1 and 2 shows the Earth's elliptical orbit, while visualizations in group 3 and 4 show the Earth's circular orbit. In all visualizations, the Sun is in the center and shading is used. In visualizations in groups 1 and 3, the Earth's axis of rotation is shown, while in visualizations in group 2 and 4, the axis is omitted. The research objectives are: first, to test the understanding of seasonal change among first-grade high school students. Second, to examine the relationship between the characteristics of visualization and students' explanation of the changing seasons, and analyze the direction of students' attention during analyzing visualization and explanation. Here are pretest results. Overall score was 56.45%. The group equivalence was checked using the Kruskal-Wallis test, which confirms that there are no statistically significant differences between groups. The qualitative data collected through the interview were categorized into 6 categories: unclear, naive, complex, naive, partial A, partial B, and correct, more detailed description of which can be found in table. 30 students' explanations were categorized as complex naive, while only 6 explanations were completely correct. The right graph shows a trend of more accurate explanation by respondents in groups 1 and 3, whose visualizations contained a depiction of the Earth's rotation axis, compared to respondents in groups 2 and 4, whose visualizations did not contain the Earth's axis. Also, the graph shows that there is no difference in the accuracy of the explanation with respect to the shape of the Earth's orbit. A little about measuring attention. Eye tracking is the determination of the object on which the gaze is focused. In our case, the determination of the area on the screen on which the gaze is focused. The image on the left shows the position of the subject and the camera for measuring eye movements. The image on the right shows how the software defines a vector that is directed at subject's gaze by determining the center of the focal reflections and the center of the pupil. To collect more precise data, the visualizations are divided into 5 areas of interest, AOIs, appropriately named sun, summer, autumn, winter, and spring. The participants of all groups focused most on the area of interest autumn in the upper part of visualization, and least on spring in the lower part. Here are measurement of eye movements results. The average number of fixation was statistically significantly higher for participants who viewed visualizations with Earth's rotation axis, groups 1 and 3, compared to the groups without the displayed axis, groups 2 and 4. Although no statistically significant difference in the total time of observing of the visualization. According to the areas of interest, the participants had the most fixation on the areas of interest autumn and sun, compared to the other 3 areas. The average fixation duration is statistically significantly shorter in the area of interest sun, compared to the areas of interest autumn, winter, and summer, which is expected since there are no details shown on the sun. Revisits to the area of interest sun is the highest, which is expected too, because of the sun is centrally positioned and central to students' explanation. There is also a statistically significant difference in total average number of revisits between the groups with the Earth's rotation axis shown, 1 and 3, compared to the group without the axis shown, 2 and 4, that indicate greater integration of information from different parts of the visualization during the formulation of their explanation. Here are 2 limitations of study: small and unrepresentative sample and very short use the visualization. It would certainly be better if a larger number of schools were included and the sample size was larger, and have insight into the direction of students' attention during a longer visualization analysis. For the end conclusions, study indicates some knowledge on the phenomenon of the change of seasons, but the results is not satisfactory. Eye-tracking data show that students did not pay equal attention to all parts of visual representation, and the display of the Earth's axis of rotation on visualization attracts students' attention and helps to more accurately explain the causes of the change of seasons and encourages the integration of information. These results provide important information to develop teaching materials that will enable students to better understand the change of seasons. Here are the references, and thank you for your attention.